Hello, my name is Madison Klarkowski, and I am pleased to present work on using functional near infrared spectroscopy to assess cognitive activity during gameplay. I'm presenting this work on behalf of my co-authors, Mickaël Causse, Alban Duprès, Natalia del Campo, Kellie Vella, and Daniel Johnson, from a range of affiliations. Video games are often heralded by the public and in the media as a cognitively undemanding activity. So we wanted to know, how does mental effort and cognitive activity differ between gameplay and this? That is, a type of activity specifically engineered to engage and stimulate human executive function, such as working memory and cognitive flexibility. There are a number of tools we can employ to assess cognitive activity. Most frequently in games user research, we see the uptake of technologies like electroencephalography, or EEG, and functional magnetic resonance imaging, or fMRI. The latter, fMRI, allows for greater spatial resolution than EEG by measuring brain activity through the detection of changes in blood flow. But it is also expensive, susceptible to noise, and largely requires the use of a logistically difficult scanner tunnel environment. But we have a relative new kid on the block that also measures brain blood flow. Functional near infrared spectroscopy, or fNIRS, allows insights into cognition through measurement of cerebral haemodynamic changes, that is, brain blood flow as detected by changes in oxygenation concentration. It is a comparatively new entry into brain activity measurement, but allows greater spatial resolution and localized insights than other measures. And it is typically a measure of activity in the prefrontal cortex, which is a locality of the brain that is often most interesting to us as player experience researchers. The reason for this is that the prefrontal cortex, or PFC, is chiefly responsible for executive control, and it can also be subdivided into three broad regions of interest: left, medial, and right. It can be divided further, but we're just going to look at these regions today. Each of these regions have associations with specific functions and processes, such as memory, language, and emotion. We also know that if we see increased hemodynamic activity in the PFC, that this is indicative of increased mental workload. Currently, work has found that fNIRS can successfully distinguish between gameplay and rest. However, distinguishing between levels of difficulty has proven more complex. There also exists a dearth of comparisons between gameplay and known tasks that induce and assess executive function. To this end, we established three research objectives. Objective 1 was to test whether fNIRS can reliably measure differences in PFC activity associated with a video game manipulation, in this instance, variations in game difficulty. For Objective 2, we wanted to examine how PFC activation patterns compare between gameplay and established executive function tests. Finally, for Objective 3, we wanted to examine whether PFC activation patterns observed during executive function tests are associated with activation patterns observed during gameplay. The game we selected was Anomaly Warzone Earth, a reverse tower defense game for the iPad in which players can select vehicles, deploy abilities, and guide their units through hostile territory. We chose this because it offered clear delineations in difficulty, possessing easy, medium, and hard difficulty levels, and because it was a commercial video game, and so representative of a game a player might enjoy in a naturalized context. For our executive function tests, we selected 3 from the Cambridge Neuropsychological Test Automated Battery. These tests included the Attention Switching Task, or AST, which provides information about participants' cognitive flexibility. Our second test, the Spatial Working Memory, or SWM, is a test of retention and manipulation of visuospatial information in the working memory. The third, the One-Touch Stockings of Cambridge, or OTS, is a test of spatial planning and working memory. We recruited 37 male participants with a mean age of approximately 21. Our participants largely rated themselves as highly experienced video game players. Within the experiment, participants played an easy, medium, and hard version of both the video game and the 3 cognitive tests, with counterbalanced condition order. So now we turn to our results, considered in light of Objectives 1 through 3. When considering Objective 1, we found clear evidence of an increase in PFC activity with an increase in video game difficulty. From this, we suggest that more difficult levels represent greater cognitive demand and corresponding mental effort. We also suggest that this confirms the utility of fNIRS in the assessment of video game difficulty. When considering Objective 2, we found no general difference in cognitive activity between difficult gameplay, difficult AST, and difficult OTS. This suggests similar cognitive demand between these tasks and similar resulting mental effort. Interestingly, the SWM actually induced the least cognitive activity. It was also the fastest task to complete, so we suspect it may have been notably easier than other tasks for our participants. When inspecting specific regions of interest across AST, SWM, and the difficult game condition, we found increased cognitive activity in the left lateral region over the medial region. These patterns suggest both problem solving and the use of working memory, specifically memory encoding, or the storage of information for later retrieval from long-term memory. Turning to Objective 3, we find associations between the OTS and the game, and SWM and the game, in the left lateral PFC. This suggests that the cognitive tasks and games are drawing on the need to encode memories and solve problems at similar levels of effort. Further, in the right lateral PFC, we find associations between difficult AST and the difficult game condition, suggesting that the AST requires a similar level of memory retrieval and sustained attention as playing the game at its most difficult. Taken together, we find that cognitive activity during gameplay is comparable to cognitive activity occurring during tasks explicitly intended to induce and test said activity. Our results add to a body of empirical literature finding that video games are not a mindless leisure activity, regardless of the popular conception. The takeaways of our study is that we have found that fNIRS generates precise, valid, and interpretable data for the measurement of the player experience. We also find that mental effort expended during difficult video game play is comparable to effort expended during executive function tasks. Finally, we find regional activity indicating spatial working memory, memory encoding and retrieval, sustained attention, and problem-solving processes are occurring during video game play. In sum, playing video games induces notable mental effort. We also find that fNIRS is an accurate and reliable measure of brain activity during gameplay and can distinguish between varying levels of difficulty, situating it as another useful psychophysiological measure for the assessment of player experiences. Thank you so much.